Chapter 15E of the textbook is all about the locus which forms the shape of a hyperbola. Before we get to the locus part, let's look at the two standard equations of hyperbola. So hyperbolas have a similar equation to an ellipse. Notice instead of a plus sign in the middle though, they have a minus sign. We have two types of hyperbolas. The ones we will focus on today are those that open horizontally, as you can see in the first diagram, and those that open vertically, as you can see in the second diagram. Notice for our hyperbola that opens horizontally, the x bracket comes first, and it comes in front of the minus sign, which is attached or in front of the y bracket. This will tell you that the hyperbola opens horizontally. The second or vertically opening hyperbola has a slightly different equation. The y bracket is always in front and the minus sign is always in front of the x bracket. The vertices are also slightly different for each hyperbola. For the horizontally opening hyperbola, we have the vertex points h plus minus a, comma k. In contrast, for my vertically opened hyperbola, we have the vertices h, this time comma, k plus or minus b. To find the asymptotes, both of these hyperbolas have the same equations, which is a little bit handy. Let's have a look at one example to clarify. Okay. So in our example, we're going to separate it into two parts. The first thing we're going to do is we're going to sketch an ellipse with the following equation: x plus 1 all squared over 4 plus y minus 2 all squared over 1 equals 1. And then we're going to sketch its related hyperbola. So generally speaking, we know a few things about the equation of an ellipse. An ellipse of the following form will have center HK. I'm not sure why I wrote B there. So if we look at our original ellipse, we have x plus 1 or x minus minus 1. So my h would be minus 1. And we also have y minus 2. So my k is the positive version, would just be 2. Therefore, we have center minus 1, 2. So I'm going to put that in. Basically, a good way to remember is whatever signs are inside the bracket, swap them, and that is what you'll get for your center. We have that a squared is 4, so I need to find a, the square root of 4, that's equal to 2. We know that b squared is 1. That means b is equal to the square root of 1, which is just 1. These two things tell me kind of like the x radius and the y radius of my ellipse. So from my center point, my ellipse vertex will be 2 units to the right. It will be 1 unit up for the next vertex from the center point. It will be 2 units to the left of the center point. That will be my third vertex. And my last vertex will be 1 unit down from the center point. Connect all your outer points together. Label some points in. So I'm going to label all my vertex points in. And I'm also going to label my center point in. My center point is minus 1, 2. If I go 2 units across, I'll get to 1, 2. 1 unit up, minus 1, 3. 2 units to the left, minus 3, 2. And 1 unit down, minus 1, 1. That is my ellipse. Of course, if you would like to, you can find the x and the y intercepts by letting x equal 0 and y equal 0. But let's look now at sketching the hyperbola related to this equation. Part of our problem is to now sketch the hyperbola. So I'm just going to write a few things down. I know that my h is still -1, my k is 2, my a is 2, and my b is 1. Also notice in the equation the x comes first and then the minus is attached to the y brackets second. This means my hyperbola is going to open horizontally. And in fact, by sketching the ellipse, I'm able to tell exactly where the vertices of this hyperbola are going to be. They're going to be at -3, 2 and 1, 2. That, for me, is one reason why I like to often sketch the ellipse before I sketch the hyperbola. Now, we can check that this is correct by using my little formula that they gave me for vertices. So we think the vertex point should be h plus or minus a, comma, k. That gives me my x and y coordinate. All right, h is -1, plus or minus a, that's 2, and my k is also 2. So I have two vertices, thankfully. First, let's check the plus. So -1 plus 2, comma 2. Well, that would be 1, 2. Or I could have the minus version. -1 minus 2, comma 2. That will be -3, comma 2. And as we can see, they're the vertices that we thought we would get anyway just by sketching the ellipse. There's only one real thing that we have to do left. Find the asymptotes. Now, I'm just going to use the equation they gave me to find the asymptotes here. And I'll give you a tip about how to draw these accurately as well. So the asymptotes for my hyperbola will be y equals plus or minus b over a, brackets x minus h plus k. Let's sub in. B is 1, a was 2, then we have x minus h, h was -1, so we have x plus 1, and then plus 2 on the end. Take the positive version, we should get y equals a half x plus a half plus 2, or y equals a half x plus 5 on 2. And then we'll do the negative version. For the negative version, we'll end up, remember, take the negative all the way through the bracket. So we'll get minus a half x minus a half plus 2. That will give me y equals minus a half x plus 3 on 2. So they are my two asymptotes. They will be the lines that my hyperbola will open towards, but not cross. A good way to draw this accurately is to draw a little box around your ellipse in which the box touches all four vertices. Now, your asymptotes should go through the center and the diagonal corners of the box. So the first asymptote that I'm drawing, mine's not very accurate, is the line y equals a half x plus 5 on 2. And as you see, it's kind of crossing that y-axis at 2.5. Then the other line, again, it will go pretty much through the center and the two diagonal vertices of the box that I drew, and that will be y equals minus a half x plus 3 on 2. And it does look like it crosses that y-axis as about 1.5. Then I just remove the box. You can remove the ellipse if you want, but there is your hyperbola with its asymptotes and vertices.